Yeah, just a message. Yeah.
Yes, sir, you are very audible.
Great, great.
Yes,
Thank you
yes,
so much.
you are.
Thank you. Thank you. When you sit on a software with a data set, you go through those steps, you learn that art. But equally important is the science of econometrics. So let me introduce you to some of the important issues. Uh, I'm sure now you can see the screen that I have shared with you, and I'll go ahead with the first thing that we will look into uh, is the idea that theory should always be placed before econometrics. This is a very important idea, and this is what I would like to strongly pitch because that is how I was trained. What is theory? We will know that it should always be before econometrics. So you may be a very poor econometrician, but you need to be a very good theorist. So if you're a good theorist, somebody who understands the subject very well, somebody who understands how things are related, what are the complex mechanisms through which something is affecting something else, econometrics will become secondary there. uh, your ability to understand the real world is what will make you a good researcher, not your ability to do econometrics per se. It was the Cowles Commission that laid the foundations of econometric science. They themselves were very skeptical of what they developed. They were knowing the boundaries within which the econometrics should be practiced and the boundary beyond which econometrics should not be interpreted as a serious exercise. There was a very big blow, something known as Lucas's critic. A very well-known paper is there by Robert Lucas. He threw the entire science of econometric work into, I would not make a very wild statement, but literally he threw it in a shock way. Everybody was caught, shocked, not prepared. Just like in 2008 financial crisis, when many of the economists were unable to forecast it. So the idea was that relationships that you are trying to quantify using econometrics are themselves changing as soon as you create a policy related to that particular issue. For example, if you want to change inflation and bring inflation down, your very act of trying to reduce inflation will start changing inflation in a different direction. Uh, I would not go bore you with too much of theory, but this is a very solid idea. We'll look into that. I'll also like to talk about model-based thinking. How you look at the world as permutation and combination of uh, x and y variables. Your dependent variable and independent variable. You start looking at the things around you, the world around you, as a equation. And you keep finding various equations where there is a y variable and then there are various x variables, and you start thinking in that direction. Then you will be able to develop a better understanding of econometrics. Otherwise, it might become a mechanical exercise. We will also look into the third topic, which is what are econometric models per se. And after having done that, we will look into the most important 6 elements of good econometrics. If you want to be a good econometrician, uh, I'm not talking about great. I'm not a great econometrician. I consider myself to be an average econometrician. If you want to be an average or a little better than average econometrician, these are the 6 things that you should know about very well. You should have very strong command over them. What is the logic behind them? you know the 6 things: identification problem, endogenous variable, exogenous variables, functional relationships, stochastic element, and the estimators. I will talk about all these very quickly, don't worry. And finally, you should know about the types of econometric models that are being popularly used. I will give you some illustrations about them. Lastly, we will go on the case study, and I have prepared a simulation case study. By simulation, I mean to run different scenarios and see what happens with your y variable. In econometric modeling, what are you interested in is your y variable. That y, your dependent variable or the endogenous variable, is what you are interested in. Everything is around it. Your entire thinking has to be around that variable. Many times I have seen people who do econometrics, they focus on the x variables and then they somehow force that x variable to become related with the y variable, which is known as data mining. You keep running iterations and regressions. In Gretl, for example, you keep running regressions 100 times, 150 times. Finally, you will find a correct combination of X and Y's, which is actually not theoretically true. That is not how the real world may work. So we will look at that. My recently published book with Routledge, I'll take one case study from there. Earlier, I wanted to take a bigger case study, but I thought it would be too complicated at this stage. So I've taken a very simple data set adopted from my book, and we will have a look at it in Gretl environment itself, also on Excel, because you can't run simulations on Gretl. For simulations, the best place is Excel. If you know Microsoft Excel well, you can run any software because all your data is always going to come and get located in Microsoft Excel sheets or some other spreadsheet program that you might be using. And finally, very interestingly, I will share with you the modeler's toolkit. I mean, three important things that you should do every day, and you can start to become a good modeler. That is to do good econometrics. All right, we'll go on the first one. Theory should be before econometrics. And what do I mean by theory? The idea that you are trying to quantify using econometrics. As the moderator very correctly explained, econometrics tries to quantify, that is, put numbers on relationships. But how do you put those numbers? Which variables should you use to do that analysis? What way those variables are related? You know, for example, there was a study where the shoe length and IQ were found to be related. Of course, there is no theory that can explain that. You know, it's spurious. Okay, if I tell you, for example, Bhagirath, myself, I wake up early. Whenever I wake up early for last 6 months, stock markets on that day in the morning, Indian stock markets have seen a jump, positive jump. Does that mean that the government of India and SEBI are going to ask me to start sleeping every day and start waking up early in the day? Of course not. There is no theory here. These are correlations. These are correlations. So where is the theory? How does the theory come? As an analyst, as a researcher, from where would you get your theory? There are four things that I have put here. First is, of course, literature. You all have gone through literature review sessions in the workshop. So take them very, very importantly and very seriously. Literature is your heart. Study the literature well, go in deep, find out patterns, find out how debates are there, what kind of variables are being used, what kind of theoretical models are being proposed. By theoretical model, we mean the idea of how the real world works. Theory is not something which is in the book. Theory is something which is in reality. How does the reality work? For example, as a smart person who lives in India, you know that social security is something that we don't really have a US American kind of social security concept here. So in any theory of anything related to India, you will not bring social security as a variable because that is something which is not directly applied to Indian economy. Inflation. While inflation is there in India, yesterday I was reading an article about Turkey. The inflation is quite high there. And that is a very different environment. You won't bring the kind of analysis or ideas that you use in Turkey to analyze the problem of inflation in India. That's not possible. Two different economies, two different kinds of inflations. Inflation are also different there. You can't bring the same set of ideas here in India that you may apply in Turkey. So literature is the first source of theory. From where would you find the theory? That is the equation that y variable is a function of or related to x1, x2, x3, and x4. For example, in economics, there is a very simple theory we study, law of demand. You inverse that, see, look at price, okay, or look at demand. Demand is a function of demand being your y variable or endogenous variable is a function of price of the commodity, price of the substitutes, income, the population, etc., etc. In management, for example, if you are in HR, you can study employee performance as a y variable and find out various x variables that may explain employee performance, like the working hours, are there any night shifts, how many leaves they are given, the salary structure that they are being provided, other incentives that they are being given, the behavior of the boss. Of lately we have seen some toxic cultures coming from big corporate companies. So what is the behavior of the boss immediate to them? So this is a theoretical model. So where did this theory come from? One, it could have come from literature. If that is not sufficient, your experience will also help. That is why, as you do econometrics well after several years, or when you do something in a particular field, you develop very good command over it. That command is your experience. That will give you the theoretical idea. What is the equation that I should start looking for? Econometrics can't give you equations. I remember one lecture by Montek Singh Aluwalia, who was the ex-chairman of the Planning Commission, old Planning Commission. He was there in our university several years ago, around 10, 12 years ago. And he made a very good statement that econometrics can only test hypothesis. It can't create hypothesis. So if I want to solve a problem in the real world, it is my knowledge of that sector or industry or that area which will help me to create an equation. Once I have that equation, now I can start doing econometrics on that. So please be careful. Your theory, your subject, HR, finance, macro, micro, industrial economics, big data, AI, whatever you are working in, that is what really counts. From there, you will be able to develop that equation. And then there are some rules of thumb, like law of demand. We all know that if you are trying to create an econometric model for demand forecasting, whether for a company or an industry or the whole country, you need to include price as a variable. You can't have a demand equation without price variable. Come on, you know that it has to be there, isn't it? And then there are other ways. I attended some of the sessions earlier. I attended the inaugural session also. One of the esteemed professors talked about randomized control trials, RCTs. Many times while doing RCTs or by doing data mining, you come to know that there are some relationships, some correlations. So that can also be a source of theory, but that cannot be your primary source. You can't let data tell you what is going on. You need to make the data reveal to you what is going on. If you start trusting on data directly, then data will keep on fooling you and data will keep on telling you whatever it wishes to tell. you know so be very careful on that. The next important thing is whether you should go for data mining. That is, you start with data, look at the correlations, do some data mining exercise. Nowadays, we have this craze of AI and machine learning. So there are data mining algorithms available, data clustering mining algorithms. You can use those algorithms and see that what is the y variable and which are the x variables related with that y variable. You can do that. Your y variable and the x variables that might be related with this y variable. Another more realistic and correct way of doing it's known as structural modeling. Now, this was my actual earlier topic for the session, but I decided to reduce it and make it even simpler to communicate the most important ideas with you. Structural modeling is where an analyst, has a theory in mind. Where does the theory come from? Naturally, the theory comes from here, literature, experience, rules of thumb, vagera, etc. So you theory, and they apply that theory on the data, set up the data accordingly, and then they do econometrics. What do data mining do? Data miners, they start doing econometrics in the first go. Time series econometricians do that. When they run vector autoregressive models or vector error correction models, or they run forecasting exercises, that is where they do that. They are really not bothered with some a priori theory. They are interested in what the data says. And if you want to forecast something, really doesn't matter if you know the theory or not. Till your equation is good and able to forecast, great for you, nothing to worry. If I want to forecast the price of tomato in my city, if my equation is able to forecast it well, nobody cares whether there is some theory, literature, or experience behind it. It is doing well. That's the job. But understand, when you go for policy making, when you're trying to change something, forecasting is not enough. You need to explain it that also. You need to explain. For example, in your country, there must be government and there must be a central bank. If you are creating an equation for the central bank, you need to justify to the central bank what's the logic behind this. Why is my x variable affecting my y variable negatively? You need to explain the logic to them. They won't go around making decisions and taking decisions simply on a forecasting model. For example, if government feels that there is a problem of frequent electricity fluctuation in an area, and you create an equation to explain where, where y electricity fluctuation is your y variable, or dependent variable, or the endogenous variable which you are trying to explain is a function of x1, x2, x3, whatever x you want. You need to explain your electricity authority. Why have you chosen these variables? Why are they affecting your y variable positively or negatively? We will see that with concrete example later on. You need to explain it to them. What's the logic? What's that logic? That logic is theory. Structure. You're giving structure to your data. You're telling your data that you have to behave within these boundaries. And this is also criticized by many people. Paul Samuelson is one of those Nobel laureates in economic science who criticize this kind of approach also, that you can't have a priori advanced idea about everything. That means you are God and you know everything. That's not possible. You need to be humble. So econometrics is about putting that fine balance between data mining and structural modeling. Whether you should let the data speak for itself or you should make the data behave in a certain manner to reveal the truth. That comes only with practice and maturity. All right, there is no hard and fast rule for this. So two kinds of theories are important. We are talking about the word theory, the economic theory or subject theory. If you're in HR, your HR theory, marketing theory. If you're an engineer, engineering theory, mechanical, civil, whatever it is. If you're an economist, macroeconomic theory. If you're a macroeconomist, industrial economic theory, public finance, whatever you are dealing with, whatever is your subject area or whatever you're working in, you know, uh, inventory management, that is your theory. So that theory is what you should know very well. How things work, how things work in the real world where you are working. And second is econometric theory. This econometric theory is something which is very difficult to master because it requires lot of efforts and lot of tolerance and patience. People are in a hurry to learn technologies like softwares, for example, and start running equations. But that's not correct till you don't understand the econometric theory well. And why is that so? I will tell you later on in my session. I'll tell you, I'll give you a very real example why you should know econometric theory well. It will save a lot of time and it will help you create very good research work. See, in the end, your aim is to publish well, publish good thing, create new knowledge which can impact somebody. That can only occur when you have very good econometrics behind it. And that good econometrics comes from not good technologies, but from good theory. So that's what I was talking about. Causality, very, very big concept, philosophical concept in economics and in all other fields, and correlations. Bhagirath's waking up time and India's stock market movement are correlated, fine. But are they causally related? Is there a cause and effect relationship between them? Is Bhagirath's waking up time causing stock market? Or is it stock market's movement which is causing Bhagirath's behavior? Or maybe there is no relation whatsoever. It is spurious. So econometrics is concerned with causality, not with correlations. Statistics can deal with correlations with. But when you go to the world of econometrics, you need to have causality. And what is this causality? Your theory. Causality is your theory, cause and effect relationship. What is the effect variable? The y variable. Okay, the electricity fluctuation or inflation, whatever you are interested in, that is your y variable. Whatever research you are doing, that is your y variable. What are the cause variables? X variables that you are including in the equation. 1x variable, 5x variables, 100x variables. Really depends on the data and you. Correlation is something that you know very well. I won't waste your time on that. And in social sciences, we have a problem because causality is not very clear. In pure sciences, you at least have the freedom or the luxury of experiments. Of course, in economics, people have started doing randomized controlled trials, and there are two very big names, Abhijit Banerjee and Esther Duflo, the Nobel laureates who have pitched the idea of experimental economics in microfinance field. But that's also not applicable to entire economic analysis or to entire managerial world. There are some areas where you can apply that. You can't do a study of all India level. You can't create a randomized control trial for entire country or entire region. It's impossible. I mean, you will end up making hundreds of errors in that. Only for very small places you can use this kind of randomized control trials. So in social sciences we don't have that experimental freedom. So what we do, is we use econometrics to create equations. Those equations allow you to do experiments. That one experiment we are going to see today in the simulation exercise. The econometrics allows you to do experiments. I mean, what's the practical reason why we use econometrics? Because we are not physicists or chemists who can do experiments in lab. We do experiments in econometrics. We create equations and then we change equations, x variables and their combinations, and we see how y is affected. That's the idea behind econometric modeling. This is the theory or basic idea that x is, which is an independent variable, also known as exogenous variable. They are not exactly the same, but let's consider them equal, is related with y, that is dependent variable. See the term related, and below that term, below this term, you have causes. Very different, very different. How do you know x causes y? By your theory. Where does your theory come from? Your literature, experience, some rules of thumb are there. People know this is how things work, and data mining maybe. But relation is something that can be everywhere. You can relate anything with anything else. There's a very good saying by Mark Twain or somebody else has said that if you torture the data enough, it will confess. Keep torturing your data, and finally it will say, yeah, Bhagirath, you are true. You are the most ultimate econometrician in the world. Nobody is as great as you, and you are the next Nobel laureate. Data will speak it if I make it speak. But if I want to know the truth, I should allow some theory to play a role and then let the data do its magic. So second is to learn model-based thinking. When we say model-based thinking, that is you start looking at world as a combination of x and y variables. For example, if you are concerned with pollution in your area, your air pollution, for example, let's say you are somebody who is very upset with the air pollution in your city or area. Air pollution becomes your y variable. Now start looking for the x variables around you. Start experiencing, start going on the ground, read some literature, and you can create an equation. This equation is not econometric equation, it's still a theoretical equation. But that is very important. If your theoretical equation is good, everything else can be made better. If your theory itself is wrong, you may come up with great econometrics, but it will be caught like this in a flick of a moment. Somebody who has very good knowledge of that subject and econometrics will catch you and will tell you that your very idea is wrong. In air pollution equation, where air pollution is a y variable, you cannot include something like number of hours people sleep or something really weird. For example, GDP of the country. You're looking at air pollution of a city and you are using GDP of the country as X variable. Now, come on, you can't do that. You can't. I mean, what's the logic behind country's GDP affecting air pollution in that small tiny part of that country, which is your city or area? There are quantitative and qualitative models. There is a very wrong idea that qualitative models are qualitative, so they are not quantifiable. They are quantifiable. I think one of the sessions yesterday was on qualitative modeling itself, logit probit model. So even if you have qualitative data like gender based data, male female, or yes no variables, whether you have liked the product yes or no, marketing people collect that kind of data. Fine, you can still do a lot of econometrics. Most of the econometric tools are available for you in a different form. So everything is quantifiable. If it is not quantifiable, it cannot be analyzed. Then really there is no basis to analyze it scientifically. That's the truth. Till now, quick feedback, everyone. Are you able to understand whatever I have discussed till now? Everyone is fine. A thumbs up reaction can be good, or you can write in the chat box. Till now, whatever I have been discussing, am I able to communicate my ideas well to all of you? Yeah, you are responding in the chat box. Please keep responding. Others also may kindly respond. And if there is some issue, you just let me know in the chat box or put a message in the chat box. Yeah, I'm
going quite fruitful and participants are enjoying.
Great. So I'll continue.
Yes.
Yeah. So there is a wonderful course for all of you, which I am going to show you today. It's known as Model Thinking on Coursera. A beautiful course. It does not teach you econometrics. It teaches you how to think like a modeler. How do you model the world this is your ultimate technology, this brain of yours. Everything has emerged from here. So you
Hello.
create. Yes.
Hello.
Yes, madam, please.
Sorry, sir. Sorry.
So I request the participants to keep themselves muted. So there is a very good course on Coursera. Just excuse me, I'll have water. Called Model Thinking. I'll share the details with Dr. Firdaus Malik. He will be happy to forward it to you. Uh, take the course, start going through it. It's a little bit difficult, but not great. We all are smart people. You know, so just go through it. You will enjoy it. You will learn a lot of new things. You will start looking at world as a as an equation. You know, there are so many equations around you. You know, that's what you need to do. Fine. We'll go on the. There was a small exercise, but let's not put time in that right now. A very good quote from that Coursera course itself. You know, which I found, which I thought I'll share with you. By wisdom, I mean an understanding of which knowledge to apply. So, what is wisdom? Wisdom means you know what is the knowledge that you should apply in a particular situation. Almost by definition, complex situations will always have multiple forces at play. So, in an equation, you will not have one x variable, but many x variables because everything is complex. By complex, we mean there are multiple layers of reality. So, wisdom requires the capacity to identify those components, that is, those x variables. Wisdom is when you know which are those x variables that I should use for my y variable. One can have complete knowledge of the human body's functioning, but it takes wisdom to know how to cure. Very important. You may know completely about how the econometrics may work. Say, for example, you are very good in a software like R or Stata or Gretl, but how do you address a problem? How do you estimate a beautiful, nice equation that explains the reality? And when you send it to a top class, top notch journal, they see that and they see, wow, what an estimation, what an equation, what a beautiful equation. So well captured. You know, how do you do that? I mean, that comes with wisdom, with practice, with research, with study, theory. In the end, theory is what will guide you. Nobody will be impressed by your econometrics. It is your theory that will impress them. What are the variables you are linking? What is the y variable? What are the x variable? Something new in those x variables. And then maybe some new methodology you are using. Those things are important. All right, fine. So let's look at quickly what are econometric models. Um, there are many different models everywhere. There are diagrammatic models you can create in systems theory in maths. They use that. They create diagrams, systems, and they link them. In production management, I've done bachelor's in management. So we studied a specialization subject called production management. In production management, they teach us how the entire layout of a factory should be set up through diagrammatic models to minimize the time that uh, the assembly line workers may take to go from their place to washroom and then back to their place. So these are diagrammatic models. There are mathematical models that mathematicians use, engineers use. There are statistical models that for use in forecasting, vagera. You know, you use t-test and hypothesis testing on that. There are theoretical models. Theoretical models are at the heart of everything. In econometrics, particularly, theoretical model is very important. If you have a good theoretical model, econometrics can always be taken care of. If you don't have a good theoretical model, you will keep on doing econometrics, and believe me, no good journal will be able to accept your work because they will come to know that the theory is very weak. It may happen that you have discovered something really new through data mining. That's a different thing. But that's something which happens rarely because so much of research is available on everything. So one of these models are econometric models. There are three components. What do econometric models do? They take mathematical models. I'll show you how a mathematical model looks. Very simple actually. When you'll see, you'll say, come on, this is very simple. Why do they use so fancy terms? Mathematical models, statistical models, and you mix them together in a fine combination of causality, cause and effect relationships that we were talking about. So when you link mathematical statistical models with causality, you come to what are known as econometric models. How do econometric models help you? They quantify the real world. They allow you to do experiments. You can plug in different values of x variables, and then you have a y variable. You can run different scenarios and simulations that we will do today. Those are the ways in which you can use econometrics. It's a very wonderful tool if you know it well. It can allow you to answer many questions that otherwise you cannot answer. So what are the fundamental elements before we go on our case study work? Very important. Philosophically, theory and experience are the two important things. No book can teach you. You need to study, you need to experience, you need to work on different data sets. And with time, you will learn that in your area or whatever field you are working in, this is the theory, this is the equation that should work. And if some new guy comes or girl comes and creates a new equation and tells you that this is how things should work, you are going to question them. You are going to criticize them and correct them that no, your understanding is wrong. While your econometric model is very good, the theory behind it is very wrong. So we can't use it. It's not reliable to go ahead in the real world and do anything. So theory and experience. What are the technical elements? This can be learned easily. I'm going to share some books also in the session and later on through Dr. Firdaus with all of you. Those six elements, the identification problem. So uh, identification problem is what kind of data will you use to analyze the x variables and the y variables, like inflation. So inflation is your, let's say you're worried why is there so much inflation in Turkey, for example. There's a lot of inflation. So Turkey economists would be interested to know how do they reduce inflation. So inflation will be the y variable. Now how do you measure that y variable? Inflation can be at the entire country level, it can be for a particular commodity, it can be for a particular sector, etc. That's a problem, isn't it? So how do you measure it? How do you identify the correct variables, the correct y variables and the correct x variables? Identification problem. This only and only can come through theory and your interaction with people. Go on the ground and interact with people. When you are trying to do some research work and create some equation, analyze anything, even if there is no equation, go and interact with people who are working in that area. Go to good conferences, meet them, interact with them, develop a network. JKEA, Jammu and Kashmir Economic Association, will be conducting many workshops and conferences in coming time. I'm sure Dr. Firdaus will agree with me. So during those times, yeah, so during those times, you can come and bring your research work, show it to me, show it to other experts, show it to Dr. Firdaus if you are working in his area. Show it to them, share with them, tell them, give me your comment. What do you think about this? You'll perfect those gray areas and you'll sharpen your equation very well. So what are the next five important elements? The endogenous variable, the dependent variable y. I have shared an Excel sheet with all of you. In that Excel sheet, there is one variable called output. That output in that Excel sheet is your y variable. When I'll open the sheet, I will show you. Exogenous variables or independent variables are the variables which will explain your y variable. That is, as per your theory, as per your experience, as per your knowledge, you believe that this is the x1 and x2 variable that can explain my y variable. In the Excel sheet, we have output as the y variable and labor and capital as the x variables. Those in economics will quickly understand we are talking about a production function. Those from management will also be able to understand it's an input output process. Okay, so there are inputs which are your labor and capital, and through an equation they should produce an output which I have given you in the Excel sheet. Three variables are there: output, labor, capital, y, x1, x2. The functional relationship. Now, this is where it becomes tricky. How do you link? What's the form of equation you should create? You know, so what's the form of functional relationship, the mathematical relationship that you will create between your x variables and y variables? There are many different functions like translogarithmic functions, log functions, linear functions. There are growth rate based functions, exponential functions. There are many different functions that you will find in standard textbooks. So study them and try to understand the logic and apply them to your area of research. Which kind of equation, in what form your variables should enter, your data should enter into the equation. As it is, first difference in time series, we have this stationarity problem. So people go on doing first differencing or take growth rates, etc. So is that's the correct way to enter the variable? That's the function relationship you want. Or you can have a non-linear functional relationship where you can have y as a function of x1, x2, x1 square, x2 square, quadratic function. Or y is a function of x1, x2, x1 square, x2 square, x1 cube, x2 cube. You can even have a more complex function, y, function of x, y, and x into y, interaction variable. So you can create many function relationships. And if you don't know the theory, economic or your subject theory and econometric theory, you may end up choosing the wrong function. So you need to be very careful at that time. The stochastic element, this is the headache of every econometrician, every modeler. The stochastic element, that E, that random term, error term that we introduce. We may not call it random per se. It should be random. It may not always be random. That stochastic term, we will see that in equation form. When you introduce that term, that is where the problems arise, and modelers and econometricians start stretching their head. What is to be done? How to deal with it? How to keep it controllable? You know, that's very important. Study about that element, that stochastic element. Whatever books I will share with you through Firdaus Malik sir, you will be able to learn about it very well. Learn about it. What is this stochastic element? What does it mean? How will it affect your equation? If you remove that stochastic element, there is absolutely no fear. Go to the software, put the data, press click, and done. But softwares will not do that. They will always introduce a stochastic element, because softwares also know that in reality you can never understand anything with 100% accuracy. So in reality, you cannot say that y is affected by or is explained by x1 and x2 only. There are always going to be some x which you don't know about. Okay, there are always going to be some things that you don't know about. In economics, human behavior can never be 100% predicted. Some residual will always be left. So you need to ensure that that stochastic element residual comes under your control. It should not be volatile or unstable or mad. It will be there, no problem. Errors will be there, but errors should be manageable. Then your equation becomes reliable. And lastly, estimator. Estimator is those B coefficients, beta coefficients. I'll show you right now. See, here is an equation that I adopted from my book, where y is a function of x and betas. Betas are those regression coefficients. You can see below that I have given an actual equation from my book, where y is a function of a, L is labor, K is capital. So those, that B1 that you see, small b1, b2, those are the betas here. This is what you are interested in as an econometric modeler. You want to know these B1s and B2s, put a number on them, find a number for them. Once you have them, you can know the relationship between this L and Y, or any X and Y. That's the main area of problem, an area of work in any econometric modeling. Your betas, the beta coefficients. So the y is a function of x and beta. This is one component. This component, this much till your betas, is known as the mathematical component. There is no error. If you remove this e from here, it's a deterministic model or a pure mathematical model. Where do you use pure mathematical models? In those who are in production management or inventory management, they might be knowing about linear programming. In linear programming, you use these kind of pure mathematical models. There is no error allowed. Everything is well defined. But once you allow this E to come up, which says that Y is explained by X and betas. What are betas? Coefficients for each of the X. Here, the X1 is your labor. And what is the beta for it? B1. X2 is capital. What is the beta for it? B2. And some error, some stochastic disturbance term, which we assume that we don't know anything about it. This E is what you don't know anything about. But good econometrician knows how to bring this E under control, keep it under control. You can't eliminate it, but you should keep it well behaved. You know, we call it that residuals should be well behaved. Okay, so this error term should be well behaved in your econometric analysis. So this is an example of an actually estimated model that I have done in my work, which has been published. It's a production function. Those in economics will know. For management people, it's an input output analysis. These are the inputs, L, labor, and capital. So people and machines put together will produce something for you. Whether in banking or in manufacturing or automobile, doesn't matter. That's the core theory here. That you take people and you take machines and technologies, put them together, and you will get some output, which is your Y variable. I hope till here we are all right. Now we are slowly moving towards the case study. So these fundamentals are very important. Just put a message in chat box. No need to unmute yourself. This is the actual estimated model that I have reported in my study in my book with Routledge. So these are the coefficients, the betas that we are interested in. Some betas are very big, some are small. In model 1, they are very big. In model 2, they are quite small. So I was facing this problem. Uh, I was facing this problem in model 1. There was problem of multicollinearity. Many of you might be knowing about it. So I use something called ridge regression and control that problem. So fine, all those things are fine. But you see these betas, 0.85, 3.49, 0.02. This is your econometrics. This is what people are interested in. This is what people are interested in. But these can be good. These coefficients 0.85, 3.49, 0.02, minus 0.16, they will be good and reliable only when this E term is well behaved. If your residual is not well behaved, it is increasing or continuously decreasing or highly volatile, then these numbers are to be thrown in a garbage. These numbers are to be thrown in a dustbin. They will be of no use. They would look fancy. They would look very great. People might feel impressed with you. Oh wow, Bhagirath has created a great table, but it won't make any sense. So always remember, as an econometric modeler, this is what you are interested in, your E, the residual. So spend time on that, study about it, research about it, learn how you can manage it, and then you'll be able to do well. I'm sure. Not a big
So,
issue. Yeah, somebody unmuted themselves.
so sorry to interrupt.
Please go ahead.
Yes, sir. Sir, is it always compulsory that we like there should always be an or there will always be a unexplainable part, which is you're calling is an error, unexplainable part error. So
Um,
in the equation, like
Correct. Got it.
let's say if we have a definitive relationship, say we want to estimate the price of a product
Correct.
or price of a land, let's say, so we take input as area, which is
Correct.
length and breadth, and let's say you want to include some fixed cost, so
Correct.
we include that, and we there is a very definitive relationship there, like we directly get the price. Like, do
Correct.
we need error in such situations, or in all situations do we need error or the unexplainable part even in definitive relationships?
Okay. That's a very nice question, Mr. Ramakrishnan. Everybody should appreciate this kind of question. It also, I feel happy that people are getting the touch or the gist of what I'm trying to communicate. So as far as the E term, the residual, the unexplainable part is concerned, when you are taking land prices and you want to estimate or forecast land prices, when you say that there is a definitive relationship, you are saying that in that region or area, land price will always be determined by area and some fixed cost variable. This is something that not everybody would agree. And you yourself, when you estimate an equation, when you actually go and suppose, for example, you remove this E and you start estimating the equation, you will see that if you go backward forecasting on, you apply that on the past data, let's say past 10 years data, you will find that your equation is not able to forecast the land price with 100% accuracy. You are always either over forecasting it or under forecasting it. So what's the idea here? That other than area and some fixed costs, there are some other factors. Like for example, if that area is located in a hilly area, agroclimatic conditions could be one factor, government taxes could be another factor. So there may be some factors, at least one factor that you will never come to know about, and it's always going to create problem in your estimates. Because when you forecast land price, let's say to be 5,000 rupees per square feet, which is a standard measurement unit in India. I don't know about other countries because there are many international participants also. But square meter, let's say certain dollars per square meter. That's the language of real estate world. Now, if you are estimating that particular variable and you have two variables, area and fixed cost, you will find that whenever you are estimating and creating a forecast or any number out of it, it is never going to be exactly equal to the actual data if you put it on the back, if you go for backward forecasting, or
Mhm.
even you go for forward forecasting, forecast for 3 months from now, keep quiet, wait for 3 months, and you will see your data will always be different. Your estimate will always be different than what is the reality. This simply means that in everything there is something which is random in nature. something which is simply wild and random. You can't do anything about it. Human behavior, everything emerges from human behavior. Land price also emerges from the decision made by landowners who are humans. So there's always going to be that some random element, some erratic element. Bhagirath might stand up right now and switch off the session and just go away, and it may happen. I'm sure it will not happen. Dr. Firdaus is also very much sure it will not happen. That is why he is kind enough to invite me. But some emergency may occur right now, and I may have to immediately rush. There will be some erratic component, something which you can never foresee or forecast. So error term, residual term, stochastic disturbance term will always be there, has to be there. Acha, in Mr. Ramakrishna's question,
Yes.
where can you choose not to include it? when you are doing when you are doing a highly accurate experiment in a lab. Even there they allow error terms to be included, but in those cases you may ignore the error terms safely. I'm not saying this is the correct thing. Those in pure sciences may not agree with me. I may be wrong at that time, but those are the places where you can have very definite relationships. Because you are controlling everything. For sure this is what I should control, and this is how this will behave. But in the real world, the social world around you, the way people are interacting, making opinions, developing perceptions, builders, the way they are making decisions, the demand and supply, it's so dynamic. I mean, you can't afford to remove that error term. So my suggestion is, no, you cannot. You always need to have this, even if you are 100% sure these are the only two variables that explain my y variable. Be on the safe side. Always include this. What you can show is, after your estimation, and after the estimation, I don't know if I have included this here in this estimate. Yeah, I have included. See, r square is here. After your estimation, you can say that there is error, but I am able to explain 95% of the y variable. So my x variables here, labor capital, labor square, capital square, and labor into capital. These five variables are able to explain my y variable, which is the deposit, the output. 95% of the variation, 95% of the variation in that dependent variable, okay, that y variable is explained by my x variables. So I am not able to understand only 5% of it, and that's not a great thing. That is fine. It is going to be there. In many situations, even 50 or 60% explanation power is also good. So what I'm trying to say is, if you don't include this E, you will never come to know this 95 versus 5. It will always show 100%. And that's really not correct, because you will always see that your forecast or estimates will be different than the actual data. Slightly, it may be very slight. There may be very slight difference. For example, here it's only 5% difference on an average, but it is there. You need to appreciate that. As a scientific analyst, you need to allow and tell people that this is my ability to explain 95%, 80%, 70%, and I'm not able to explain this much component. I hope I have cleared your question, sir.
Yes, sir. Sir, can I follow up
Yeah,
if it
please.
is not time consuming?
Yeah, you can, or you can keep the question on hold and we'll take it in the Q&A round. If
Sure,
you,
sir.
no?
Okay, okay.
Okay, thank you
Thank
so
you.
much. Yeah.
Thank you.
I'm sorry to stop you, but we have a Q&A round and we'll take up
No,
questions
no, no,
there.
no, no, no.
Yeah,
I
yeah,
understand, sir.
yeah,
Time.
yeah.
Yeah, thank you.
Yeah, so these are the major types of econometric models, everyone, that are being used. Single equation models where you have only one equation, and then there are cross-sectional data, which is measured for a single unit, for multiple units for a single point in time. So you want to measure uh, the employee satisfaction level of 500 employees in your company as of today. That's a cross-sectional data. Time series, you take up any one employee from there, any one cross-sectional unit, and see their satisfaction level for the next 10 days or 15 days or 1 month or 10 months. That's time series data. You take all 500 employees, all your cross-sectional units for next 1 year, every day becomes your panel data. So there are single equation models where only one equation, where y is a function of x, 1, x2, vagera, etc. That one equation explains everything. Then we have multi-equation models in econometrics where you have more than one equation. So you have an equation for y, you have an equation for x1 also, and you can have an equation for x2 also. So there are multi-equation models. In time series, I have a little bit understanding of vector autoregressive family of models, VAR models. There we use a multi-equation frame. You model multiple equations. And then lo and behold comes the emperor of all models. Okay, the simultaneous equation models, the toughest to estimate, Very few research will be available in economics and management sciences and other fields also. Don't confuse this with structural equation modeling, SEM. That is a different thing. Simultaneous equation models, SEMs, different SEM. In econometrics, SEM refers to simultaneous equation models, not structural equation models. Simultaneous equation models are a headache for anybody to estimate. In India, the Reserve Bank of India, the central bank, has some form of simultaneous equation model for the country as a whole to forecast and estimate its interest rates. Other countries also may be definitely having it. So these are some for your knowledge. So finally, we come to what you were looking forward, simulation case. This is my book from where I have adopted it. I will share the copy of the book also. Please have a look at it. Please read it. I have done a lot of hard work. It will be great if you can read and appreciate and put your comments and view on that. And this is the conceptual framework of our case study. Now I'll take you to the Excel file before we go to Gretl. Very important to look at the Excel file first. I've shared the Excel file on my screen. I'm sure you all also must have received this Excel file by Dr. Firdaus Malik. Your output is the Y variable. All right, this is your Y variable. And labor and capital here are your X variables, and X1 and X2. And now you want to relate labor and capital, that is X1 and X2, with the Y variable, which is output. I'll keep output in yellow color, and I'll put my X1s in some another color, let's say light blue. So what you want to do is look at this sheet and uh, link or connect labor and capital, L and capital. So what's the logic for those who are not from economics, may not know about production theory, production function? You need some inputs to produce an output. Okay, to produce tea or coffee, you need milk, coffee powder, machine that may be used for brewing, sugar, teaspoon, vagera, etc. So here the person who will do it is the labor, and all the equipments that you will use for this is capital. Your teaspoon, machine that you'll be using, etc. And once you combine them, you will get your output, your cup of coffee or tea, whatever you prefer. So once you have the data in front of you, look at the data and just appreciate the beauty of data. Spend some time on the data. Look at the classifying variable, which is year. So you should know this, what kind of data is this? Cross-sectional time series panel. Which kind of data is this? You can write in chat box.
Time series.
Time series. All right. Others also may respond. It is time series data. Okay. Of course, correct. Very well. Very, very quick to understand. So why is it time series? Because you are recording this. What is this data about? This is about the entire banking sector of the country, commercial banking sector of India. Okay. We are looking at what is the labor that they have used, what is the capital that they have used to produce output. Here I have measured output in terms of loans. Okay, which I'll show you in the presentation file also. This is how it looks. The conceptual framework. Very important to know your conceptual framework. The labor, capital, you are linking them with output, which is your amount of loans. But how do you link them? The functional relationship, that element, functional relationship. I'll go here. This functional relationship here. What's the functional relationship that you would adopt? In theory, you will find many functional relationships. We are taking a very simple linear function. Okay, linear relationship. Labor and capital are linear related with Y. Very simple production function, which is not correct. I'm not going to show you what I have done for my book. I am using that data, but I'm going to show you something very simple. Okay, so don't say, "Arey, yaar, Bhagit is a resource person. He doesn't know even this much." That's not the case. Okay, I know that. I have done all those things in my book. I'll send the book copy. You can refer it. Here, I'm not going to worry much about the correctness of things, but to show you how the software works. My theoretical part is over, which I've done. So when for the empirical exercise part, I'll not worry much about the theory. So if question comes, you can raise, but please keep this in mind. So the production function is Y is a function of labor, capital, and I'm introducing E because I know that labor and capital are not enough. There is something called technology in economics. Okay, which capital is not technology. This is a very wrong misconception. Capital is not directly technology. Capital enables technology. Okay, technology is something which you can't really see. For example, the learning curve of employees. Is it labor? Is it capital? What is it? I mean, you can't put it on one employee or one machine. So there are some other factors other than labor and capital. There will be electricity that is being used by all banks. We are talking about the banking sector of the whole country. They must be using huge amount of electricity, isn't it? Those things can be one factor. Monetary policy, interest rates, so many other factors are there which you can include. So we are putting all those in E. Now, why am I doing that? Why am I including only two, labor and capital? I believe as an analyst, as an econometrician, I believe that when I do this econometric analysis, labor and capital are more than enough to explain my Y variable. I don't want to go beyond that. There may be 100 factors, but I am happy with my labor and capital. That's up to you. So what will happen? You will not be able to explain everything in Y, but you will be able to know how labor and capital affect Y. So that R square I showed you, this here, R square, this is 95% here. It reduces to 55% or 30% or 40%. I mean, you are fine with that. As a researcher, you may be fine with that. If I include only labor and capital, my R square will be 50. I'm happy with that. I'm more than happy with that. I'm not interested in forecasting it. Very important where to use which variable or parameters. R square should not be used simply to decide which model is good or which is bad. Your theory should be used. Even if R square is low, you can still put your result in your research and showcase it to the world. Because for your purpose, having high R square is not important. All you want to see is how labor and capital affect Y. All right. So keep this idea in the back of the mind. Some of you may not be able to really uh, understand this idea. Why am I saying that? Because in statistics, I have seen statisticians pushing lot about R square, increase your R square, low R square is very bad. That's not the case. It's up to you. You have to take a call as a modeler, as an econometrician, when you sit with data, whether you need to achieve high R square or achieve good explanation, even if with low R square. Like in cross-sectional data, where time is not available, time element is not there, R squares are generally very low. If there is 95% R square in cross-sectional data, you should be worried about it. Okay, then you should be worried about it. Then you have done some manipulation or gimmick. Fine. So we'll first quickly go to Excel and understand the data set that I've shared with you, and then go to Gretl. This is the data, and I've given you 3 worksheets, Excel sheets. The third one is data explanation. These are the explanation of the data. Very important as a good econometrician to spend time on your data. Even if it is a simulation case study example, still you should know about the data well. What do I mean by know about the data? Know about the variables well. What are they? How are they defined? From where did you collect the data? Are those data reliable? Are they from official government agencies? If they are from different agencies, are they comparable? If they are not comparable, have you taken that problem into account? For example, like Ramakrishnan ji was saying that if the relationship is definitive, uh, why can't we ignore the residual? Your measurement may not be definitive. You know that area of the land and some fixed cost affects land price, but your measurement of fixed cost, your data of fixed cost may be very problematic. It may not be perfect. It may not correctly measure the actual fixed cost that you are trying to understand. So again, that E will come. E will have everything: measurement error, this error, specification error, different X variables, missing variables, everything will get together clustered into that E that we saw. So we have the variable loans from commercial banks, which is our buy variable or output. So in my study, I have looked at different output measurement frameworks in banking and insurance industries. The idea of what is output in car industry, automobiles, is very clear. In mobile industry is very clear. But when it comes to banking, particularly because it is intermediation service, it's a very hazy area. Some people say it is deposit, which is output. Some people will say it is loan, which is output. Some people will say combination of all these is output. And there is a long debate. So that is a debate I tried to address. I'm taking one small part of it to show you as a case study. So output here is measured in terms of US dollars. Okay, not millions or billions, as US dollars. Numbers are very large. If you look at the data set, output numbers are quite large. So they are say it is our output of Indian banking industry into year 2000 was 233,118,185 US dollars. That is what it means. Input is in terms of number of people who are employed by the banking industry, commercial banks in India, scheduled commercial banks in India. It measures in terms of number of persons. And for capital, I have used the number of branches, which is like a fixed capital of banking industry. There is again a lot of debate. I'm taking one part of it. Many of you who are from banking background may say, no, this is not correct. Keep this in mind. My book addresses it. I'm not taking all those things into account. So these are the data sources from where I've collected. As you see, all the data sources are consistent. So I've collected from the same data source. This is very good because your comparability of data will be better. Your E term, residual term, will not include measurement problems or differences in the variables, etc., etc. So those things can be handled. So if you do your theory well, collect the data properly from good sources, study the data, you can reduce your E term quite well. Of course, your numbers will not always match the reality, your equation numbers, but they will not be very far away either. Okay, they will not be very far away either. So that's the beauty of spending time on theory and data. Fine. So we'll go on the raw data. And now from raw data, I have second sheet called simulation. In the simulation sheet, I have already given everything for you. So I'm going to show you an overview. You use this Excel sheet at your home and sit on it and keep running the simulations. You can even complicate the simulations also. So I have put the data of labor here in yellow color. You can see that. Capital, which is your X2, labor is X1, capital is X2. And then we have actual output, which is your actual output data, which is available in your Excel sheet here. Which is available in your Excel sheet here, which I have also given you here. Actual output, actual data that was reported by the Government of India, Reserve Bank of India. Now, what I wish to do, I wish to create an equation using which I can use labor and capital to estimate output. I have actual output data with me, which is already given by the central bank of the country, Reserve Bank of India. I want to estimate it. I want to see how well I am able to estimate with my equation, with labor and capital only. This is my estimated value. How did I come across it? I need to estimate a regression equation for it, or an econometric model. What is an econometric model? The most basic econometric model is a regression equation. How do you estimate regression equations? You may use probit, tobit, var, structural var. You can use various time series state space modeling techniques, or you can use our simple old ordinary least square, OLS. No, it's the best way to go ahead with any data, assuming that you have taken care of the issues well. People have a fancy idea of using very complicated methods, and then they come out with simple result that price negatively affects demand. Everybody knows price negatively affects demand. Even OLS will tell you that. So why did you have to go for all these complex equations and create a narrative and then come across a very simple result? I have come across many such papers in conferences and journals where I see very complicated econometric methods, but the results are quite common sense based. I mean, if I would have used OLS, same results would have come. Some numbers would be different, but overall picture would remain the same. So, of course, you may not always use OLS. You may go beyond it, but you need to have a very strong reason for it. Should be very, very strong. Have a strong econometric reason, theoretical econometric theory reason behind it. So we have labor, we have capital, and then we have actual value. Now, where do I find the coefficients? The constant term, the B1, which is the labor's coefficient, and B2, which is capital's coefficient. Now we go to Gretl. All right, so I'll load the data in Gretl for you. Let me open up Gretl first. I don't know, this should have some option of see, I reinstalled Gretl, so that created a problem. I shouldn't have done that. No problem. Let me. Just a moment. Give me 1 minute to correct the things at my. So in the meantime, you just have a look at the Excel sheet that I have given, the simulation sheet that I have given you. That simulation sheet shows you how we have run the simulation. What do I mean by simulation? Take different scenarios of labor and capital and B1 and B2s, and then see how your Y behaves. That's what simulation is about. I am removing Gretl from my computer and reinstalling it. And you also be careful, if you already installed Gretl, don't reinstall it again. All right. If you already installed it earlier, please don't reinstall it again. Otherwise, it will create troubles for you. And very good thing about Gretl is it's an open source software, and they keep on improving their program. They keep on introducing new extensions. So you always have something new coming up. And most of us won't really need to worry about more advanced versions of Gretl. Most of the things are available in the basic version. The only problem occurs when you want to do something really like advanced state space modeling in some field. I also don't know much about it, but some of my colleagues and friends do that. In those times you will need to install extensions of Gretl. Otherwise, you can be fine. You go ahead with whatever basic version you have. So you all can keep Gretl open in your uh, computers. It will take 2-3 minutes for me to finish off the reinstallation. And in Gretl, one thing is many of you who would have opened it, it's very easy to catch the idea, to get a hold of it. So it's very friendly software, very, very user friendly. I mean, it takes a few minutes. Even Dr. Firdaus Malik also said that, you takes few minutes to install and to get hold of it. Such a beautifully made software. Uh, but of course, software should not be your aim. Good econometrics and good theory should be your first aim. Once you know that well, then you go ahead with software based work. I am now about to, yeah, it is open in my computer. So now I'm sharing a screen with all of you. I don't know why my screen sharing is paused. Yeah. Just a moment. My screen sharing is paused. I want to,
I'm able to see your screen.
yeah, can you see the screen or not, sir?
Yes, yes.
You can see the screen?
Yes, sir.
Now it is available, visible. Now you can see Gretl open here, correct, in front of you. So, um, so what we do in Gretl is, before you go to Gretl, always ensure that your uh, Excel sheet is neat and clean. Keeping your Excel sheet neat and clean means your first row is defined for labels. All others have numbers. There should not be any number here. For example, something here or uh, something here. It will create error and Gretl won't be able to read the data set. So keep it neat and clean. I would even go to the extent of suggesting remove all colors and etc. Of course, it won't affect it, but I am become very extra cautious with Gretl because it's a headache when you are doing work and you know the thing, you got the theory, now you know what is to be done, and you put the file, it does not open. It creates a lot of frustration. So ensure that you define the things well, keep them neat and clean, and there should not be any unexpected or unnecessary data in any cell other than the rows and columns that you are going to use. So we'll quickly go to Gretl and we'll go to the option file. I'm sure you can see that. In the file option, I'll choose the file that I want to load, which is an Excel file. In eViews, for example, those who have used eViews, there is an option import eView file, import foreign file. No such drama is here. It's very simple. Just import a file, it will know which file it is. You can use data file, R-based file, you can introduce text files, comma separated value files, tab separated value files, Excel files. All those files can be easily fed into or put into Gretl, assuming you have properly structured it. So I have removed the file from the place. So I'll go to the correct place where the file is located. And here you won't see any file because Gretl option is chosen. Simply go for all files. I'll take the first one, which is the file that I want to open. I'll press on open. Now, as soon as you open it, it will ask you, because there are multiple sheets, it will ask you from where do you want to start importing. First row, first column, never change this unless you wish to do that. Unless you have multiple tables in one sheet and you want to only read one table. So choose that particular column number and row number. Then it will start reading file from in that sheet from that particular table. Let's say you have 5 tables in your one Excel sheet. You want to start from the fourth one. locate its column number, and row will always be 1, and then you start from there. It will start reading from there. But most of the cases, we don't need to worry about it. So we'll take up simulation data set. I think that was the file. Once I press it, it is open and the data has been loaded. You see 3 files: output, labor, and capital. Here you see the range of the data. So Gretl is automatically recognizing it as a time series data. But let's say you there is some problem or you want to change the structure of data set. You can go to the option data, choose the option dataset structure, and then you can redefine the dataset. Now, when you go for panel, it is a little tricky in Gretl, the way you should arrange your uh, data in Excel. Always set up your data in Excel, then go for Gretl. Then your work will be very smooth and you will enjoy the process. Or if those of you who are good in Stata or are, I don't know much about it, if you're good in that, you can use those files also, but you need to learn how to import it in Gretl. But I feel great. Excel is something which we all are going to use. So you consider it time series, you don't need to change it. Uh, it will ask you what frequency of time series data are you using, annual, monthly, etc. I'll, of course, it is annual data in my case. We go forward. And from which year do you want to start your data? Your first year, it is 2000 in my case, so forward. So now it is confirming the data set structure, annual from year 2000 to 2021. Press OK. It is saying no changes have been made. In other words, what was the structure before of the data? The same structure has been maintained now. You can change it to cross-sectional, you can change it to panel also. Of course, if you do that, this option model that you see, this is where we are interested in reality, it will change. Certain options will become disabled. For example, if you choose in data set structure, you choose cross-sectional data, all this univariate, multivariate options will go away. You can't use those time series models. ARIMA model, for example, you can't use this better auto-regression in cross-sectional data naturally. No. So Gretl will do that for you. So you won't be able to commit any error in modeling. Now, once you have this data, what I wish to do is first, I would like to quickly have a visualization of it. By now, you know how to create an Excel file for Gretl, keep it clean and neat and tidy, import it in Gretl, redefine its structure from time series to cross-sectional to panel if you want to. Once the data is there, you want to visualize the data, just have a feel of the data, how it looks graphically. So I select the first variable. Constant will always be there. You don't need to do anything about it. You can't do anything about it. It is by default going to be there. In actual modeling work, you may remove constant if you want, but you should never do that as far as possible. So you have output, labor, and capital. I'll keep the control key pressed and I'll select all 3. Right click. And once I do right click, first I want to see their summary statistics, descriptive statistics, their average, mean, median, their volatility, get some feel about it. So I do that, and you can either have the main statistics or you can have the full set of statistics, and it returns you this kind of table: your skewness, minimum value, maximum value, mean. I am not going to interpret all this, but it's very important to study these. If you want to do good econometric modeling, you need to study these things, know the features, the distribution of your data, study it well, spend some time on that. Okay. And then you should decide whether these variables can be used, in what form they should be used, etc. Once you do that, then you would like to look at the correlation metrics, what kind of correlations they have. This is the correlation metrics I have. And because there are time series data and we have not done any difference in growth rate, they are in level form as it is, correlations will be high because of trend element. Time series data generally have a strong trend element, and trend of any 2 variable, if they are positive, will always show high positive correlation, or if they are inverse, it will show negative correlation. Okay. In reality, you would want a data set where correlations are very low. So if correlations are very low, see, they are very high here, 0.93, 0.89, 0.86. I don't want that in reality. Here, we are not going to worry about it. You don't want that kind of data set in your modeling work. Because if there is such a high correlation, there is no new information coming from any of the variable individually. Instead of labor, just take capital and your output is still being having correlation of 89%. So capital is able to link 89 times out of 100 with output. So why do you need labor then? So if everything is having high correlation, what's the purpose of having so many variables? In reality, your correlation matrix should show very low correlations amongst themselves, but a higher correlation with the y variable. Okay. So with y variable, this should be high. But the others, for example, see here, labor and capital have 0.86 correlation, very high correlation, positive correlation. Really, I mean, they both together will not add much information to your model. Just giving you an idea, we are not going to worry about all this here. Finally, you look at the time series plot, the graphs. You can look them at single graph, but that is wrong because our output variable has a different measurement unit, US dollars and very big numbers, and labor and capital have smaller numbers. So we'll go on separate graphs. And then you get a chart of each of the three variables, get a feel of it. Time series data, it is trending, mean is shifting, variance would be shifting here. It is not stationary in nature. So a typical researcher would first focus on making them stationary. I'm not going to do all that. There are reasons behind it. Mainly, I don't want to get into complications. In my actual work, in my book, I have taken care of all those things. Okay, so here we don't need to worry about those things. But you get an idea of what you can do in Gretl. And once you do that, now I would like to estimate a model where I would like to see how labor and capital affect output. Fine. So I go to the menu option called model, and there are so many different models that you can use in Gretl. I mean, you name it, you have it. You don't have it, go to Gretl's website. They have a separate section of extensions. Use that. And I'll be taking the simplest version, the ordinary least square, simplest and the most powerful one. Okay. I will use output as it is. All right. I will take labor and capital here in this equation. I hope you can see the screen. There is an option robust standard errors. Don't choose that unless you have econometric understanding or reason that is required. Otherwise, let it be as it is. And if you don't understand something here, you have the option of help. Go there. You can also create lags of variable. You can have a lag of the y variable itself. So you enter into dynamic modeling, partial adjustment models. You can have lag of x variables also. I'm not doing all that. We are looking at the simplest case that in this year, labor and capital of this year will produce the output for this year. Past, present don't have any relationships. This year's x values will create this year's y values. You press OK and you have an equation in front of you, a work that you have done. This equation is an output of Gretl. Never ever use this output directly in your research papers. Uh, I have shared, I showed you a screen in my presentation that was Gretl output, but you saw how well defined it was with notes, titles, and proper acronyms, short forms, etc. Do all that. Never ever copy paste your any software output directly in your research papers. I've seen that in research papers. It looks very bad, and good journals will not appreciate it. That means you don't know anything. You are simply my guide, Professor K. Shanmugan, who is a treasurer, now secretary of Indian Econometric Society. He says that, push button econometrician. You press buttons on softwares and you produce something and you put it in the paper and everybody claps. That should not be the case. Be careful. Present this result only what is required. Don't present AIC or Hanan Quinn criteria or log likelihood. Log likelihood is required when you have multiple models. I've done that in my presentation file I've showed you. Because I have 4 or 5 models, I want to see which model is better in performance. Then you use log likelihood. Otherwise, don't report all these things. So this is your modeling framework. You have the constant term. All right. You have constant, which is you read any standard textbook. I'll show you right now quickly. I know I have very less time. Dr. Firdaus Malik, 10 minutes more and I'll be done. Um, then we have the two x variables, labor and capital. These are the coefficient. What does this say? It says that if labor number of employees is increased by 1, so if 1 new employee is added, it was in millions actually. So if 1 million new employees are added, the loans that are given by the commercial banks increase by 35 US dollars. That's the idea here. The coefficients are always measured in terms of the y variable, not the x variables. Coefficient values are always to be interpreted in terms of the y variable, okay, not the x variable. If you see, according to you, if you see the data here, labor, if labor increases by 1 unit, okay, let's say 1 unit, it increases loans by 35.62 US dollars. If capital increases by 1 unit, it increases the loans by 1519.33 US dollars. According to you, which one has a more powerful impact on output? Labor or capital? Quick answer in chat box. Labor or capital? Which one has a more powerful impact as per this particular model?
Labor.
No. Be careful. Have a look at it. Satyam has given some answer. Dr. Jyoti has given answer. Selma has given answer. Capital. Yes, it is capital. Why? See, you can directly compare the coefficient. The trick is compare the coefficients. The coefficient which is larger has a larger impact. This is only 35.62. This is 1519.33. So it is many times larger than that of labor's coefficient. So 1 unit change in labor increases loans by $35, but 1 unit increase in capital increases loans by 1519, output by 1519 US dollars. Yes, Ramakrishnanji, standard error is high, but it's still statistically significant, so no problem. The T ratio is fine. Okay, the T ratio is fine and it is still statistically significant. You should not bother much about standard errors of coefficients. Rather, you should look at the standard error of the regression, which is more important. Because see, some variables are weird, some variables are stable. Together, what they create is important. So I would suggest that while it is important to look at standard error, look at T ratios. It is significant at 5% level. Look at the standard error of the regression. And of course, the standard error here will be high because I have not made them stationary. These are not stationary yet. Okay, it's a very simple exercise. So I'm not worrying about all those things. But your point is correct. The standard error is high. And yet at the same time, it is still has a good T ratio. And it is not stationary. So it is going to show a high standard error. But theoretically, I've been talking about theory. Theoretically, it is showing a correct sign, positive. I expect that if I increase labor, okay, I expect that if I increase labor, my output should increase, isn't it? And I also expect that if I use more labor, my output should further increase. My theory is being applied. There are some statistical issues because the data is not stationary in nature. Okay, this is level form data. It is still not stationary. It's a non-stationary data put together. But it is for an exercise, so I'm showing it to you. You can get back to me after the session and I can show you with actual data set or explain you whatever you wish to ask. All right, so this is the thing that I have directly taken to Microsoft Excel. Okay, if you go to Excel now, this is the thing that I have taken to Excel. And these are the simulation data. Here you see the values, constant value, which is in minus from that Excel Gretl output. B1 with 35.62 and B2 1519.33. Now I put the value same for every year. Okay, I put the value same for every year, and I put the value same for B2 capital's coefficient 1519.33 also for same for every year. And then you plug in the values, actual values of labor and capital, and you multiply them. Here I put a formula for you. The sheet is with you. Look at the formula, you will understand. You're simply adding everything, multiplying within themselves. So you're multiplying labor with B1, multiplying capital with B2, and then adding constant, this multiplication and this multiplication. And then what you have, your estimated output. This is not growth, that is incorrect. It is actually estimated output. See that gap. Your estimated number is 2351918. I'll increase the screen size for you for a quick look. Okay, it is 23151918, but the actual is little bit lesser, 2331186. I've shown the residual, your error term. And if you see, there is always an error term. It is never zero. So with this equation, you can never forecast perfectly. Of course, you can manageably forecast. You can never do that. Don't ever try to do that. Otherwise, you will end up creating a too large model, which does not add much value. You will include too many X variables in the end. So don't do that. And I have put some areas in color. So my data was till 2021, but you can also forecast for 2022. For example, here I have a scenario where labor reduces to half. Magically, something happens and banking sector's employees leave or are removed due to some recession, and it is reduced to half from 1404288 to 70214. But at the same time, capital is doubled. The capital is doubled. So what happens with my output? My output is given here. This is the output, which has still increased. Look at the behavior. My output has still increased compared to the last year, even if I have reduced my labor by half and increased my capital by 2 times. This is doubled. This value I have forecasted. So don't look at this value right now. Similarly, you can run different scenarios. For example, you can now ask, this is what simulation is. What if the Indian government decides to give an incentive scheme and increase employees or laborers in banking sector by 20%, but keeps the capital constant. So you increase this number by 20%, simply like this. Okay, and you keep the capital constant as it was earlier. And this is your estimated output. Still, your output has increased compared to last year. So your banking sector is still performing well. So this is what simulation does. In simulation, we are not changing the regression coefficients 1519 and 35.62, but you can run different regressions with different kind of variables and plug in different values. I'm working on something called time varying parameters. So there you can allow this B1 and B2s also to change with time. B1 and B2 also to change with time. So fine, this was my simulation. I understand the time limit. Quickly, I will complete my presentation. Dr. Firdaus, 2 minutes more and then I'm done. Just 2 minutes more. I hope you can see the presentation file. All right. So I just want to
Yes.
go on the last sections. Okay. I just want to go on the last sections and show you some important. So we have completed these things. I showed you these things broadly. The toolkit that you should have. First is you spend some time on the model thinking course on Coursera. Very important first step. Please do spend time on it. Wonderful, free of cost course, nothing to pay unless you want a certificate. Very important. Second, you go for this particular wonderful book. Some of my university colleagues are also there in the session. I have asked them to study it. They are reading it. Statistics, Concepts and Controversies by David Moore and William Notts. Wonderful book. It will give you very good understanding of statistics and its theory. Distributions particularly are very important. Lastly, you look at this book on econometrics by Pindick and Rubinfeld. If this is not available, Damodar Gujarati Econometrics is a wonderful book. So with these 3 books, you will be able to understand and develop yourself as a professional econometric modeler. My 7 principles, I'm a very humble researcher. There are 7 principles I'm presenting to you. Okay, don't be obsessed with software. Softwares are very, very secondary remote thing. It's a technology, learn the theory well. Second, learn model-based thinking, go to Coursera's course. Third, study your subject area, develop the theory of your subject, whether you are in marketing, finance, economics, macro, micro, whatever it is. Study statistics well, that book that I've shown you, Moore and Notts. Study econometrics, Pindick and Rubinfeld, Damodar Gujarati, or any standard book you like. Practice on different data sets. Don't be obsessed with only time series or cross-sectional data. Practice diverse data sets. So you learn how different data sets can be handled and what kind of problems emerge. And lastly, take feedback. Attend workshops like the Jammu and Kashmir Economic Association workshop, conferences. Go there, talk to people, learn from them what kind of data they are working on. Know from them what you can do to improve yourselves. All right, I'm concluding. Thank you, everybody.
Sir, shall we take session for questions?
Yes, please go ahead.
Now the session is open to participants for asking some important questions. If you have any question, you can ask.
Good afternoon, sir.
Good afternoon, madam.
Sir, I'm just Kiran Kaur, Senior Research Fellow from Punjab University, Patiala. Thanks for the valuable session.
Yes, madam.
Sir, actually, I have applied panel data regression model in the Stata software, and the results that I found there are much similar to the software that we have used today. My question is regarding the interpretation, sir. While interpreting the results, I always have a problem. Like my dependent variable was in dollars, and my all the independent variables in percentage form. Like percentage of GDP, gross capital formation as a percentage of GDP, and among all the independent variable, one variable was annual growth rate. So my first question is that mandatory that dependent and independent variable unit of measurement be same?
No, absolutely no. Absolutely no. And your coefficients that you have estimated, panel regression model, those individual panel regression variable coefficients should be interpreted in terms of your Y variable only. So what do I mean? One unit, let's say annual growth rate variable, X variable, GDP growth rate. If one increasing GDP growth rate by 1%, because it is measured in growth rate form, so percentage form, by 1% will change or increase or decrease, whatever the sign is, your Y variable by certain number. which will be there in your panel regression model output. That number is to be interpreted in terms of the y variable itself.
Oh, okay, okay. Thank you, sir. Sir, I have one more question. It is apart from all this workshop, now I'm trying to apply the gravity model of trade. Can you please suggest some book which can help me, because I have gone through a lot of YouTube videos and I have downloaded so many papers, but I am unable to get the procedure of applying that.
Okay, as far as the gravity model is concerned, see, my area of study has been international finance and not trade, but I am aware about gravity model. If you want
Yes, sir.
specific references on how you want it for theoretical issues or empirical issues? You want to
Sir, I
estimate a
have to
gravity
apply
model?
that.
Achha, so
Econometric
you just
model.
get back to me after the workshop and I will share some good references with you.
Okay, thank you, sir. Can we please get your email if possible?
Yeah, I'll share the email with Dr. Firdaus Malik and he will send it to you. My phone number, email, everything, and you can also have a look at it. I'll keep the screen open. My first screen, it is written there. Those who wish to note can kindly note it. My both
You can take
research.
yeah, you can take screenshot and you can visit to
Yeah,
LinkedIn
you can do that. My phone
profile.
numbers are there. My email is there. Whatever you want.
Thank you so much,
Uh,
sir.
Yeah. Next question.
Sir, this is Ramakrishnan. I'm a student, first year PhD student.
Great, great.
Sir, so this that follow-up question, um, like you said, on those stochastic elements, which is disturbance term. So, what would you think about this? Like like we have this GDP identity equation, which is consumption plus investment plus government expenditure plus export minus imports. So that is a very definitive equation. So what?
No, no, Ramakrishnan ji, let me correct you. Those are known as identity equations in macro. We
Yeah,
estimate what are known as behavioral equations. Identity equations cannot be estimated because they are true by definition.
correct.
Accounting people use that. You can't estimate an identity equation using econometric model. That is wrong. And but where can you use those identity equations? In solving simultaneous equation models. So when
Correct.
you have multi-equation model or a simultaneous equation model, and you want to solve those equations and bring a unique solution, at that time you use those theoretical identity.
True.
But
Yeah.
you can't go ahead estimating
Yeah. Means we
identity
don't
equations.
estimate. Yeah. So means I was just confirming that. Yeah, in those identity equation, we don't use this estimation. So when there is no estimation involved.
Even if
So
estimation, you can do that. But then when you are estimating it, you should not use consumption and investment as X variables and Y as a,
correct.
because
No,
then because
correct.
what will happen, listen, what will happen is theoretically there's an identity, but your data emerge from lot of sampling. This GDP data, consumption data, investment data, they come from sample based estimates. They are sample estimates. They are not population censuses. A lot of measurement errors and other things, so their E will always come up, at least as a form of measurement error. So your E is not going to leave you when you go to the econometric world, even if you use an identity equation. So it is better not to get into econometric estimation of identity equations, rather go for behavioral equations. So look at what affects consumption, what affects investment, use them as your X variables against GDP growth or output as your Y variable. That will
Yes.
give you a much better idea.
Yes, sir. Thank you.
So I encourage participants, if they want to ask a question, unmute themselves, open their video, and quickly jump. Because we can take 2 more questions if you are having.
Good afternoon, sir.
Yes, good afternoon. Ravi.
Yes, sir.
Yes.
So this session is very interesting, and I got many insights, and this is knowledgeable session. Sir, I have one question. Currently, I'm planning to write one paper, how macroeconomic variable affects on Nifty 50 or Sensex.
Okay.
So how I should proceed, sir? Because the data, the index data, which are based on time series, which are the time series data.
Correct.
So how I should proceed, sir?
Now, this is a very, very large area of research. How
Yes, sir.
in financial economics and in macro
Yes, sir.
also, how macroeconomic factors like growth or consumption or inflation, interest rates, how they affect stock market. You should study what is known as the finance growth nexus. There is a
Yes.
whole finance growth nexus. So start from there. develop a theoretical model, and look at last 5 years top-notch, most cited research papers on this topic,
Yes.
and look at what theoretical equation they are using. Take those equations. They might be from other countries also,
Mhm.
and then you make a list of those theoretical equations. Study the finance growth nexus literature a little bit. One edited volume. Contact me and I'll share you. And then you
Yes.
come with 4 or 5 different possible equations of how macroeconomic variables can affect, what kind of macroeconomic variables can affect the index, stock index, whichever you are taking.
Yes,
And
sir.
then we can discuss further and which equation is the most suitable for the Indian economy or the current context. All right, this is where you can go. Beyond this, I cannot tell you anything. You need to come till this stage, communicate
sir.
with me and other people in your network, and then you can proceed ahead from there. Because identifying that equation is very important. Spend more time on that rather than on data or econometric modeling.
Yeah. Thank you, sir.
I request our resource person, to off the screen so
Okay.
that we will appear on the big screen for photograph. And meanwhile, we are also taking the question.
Can I ask a question, sir?
Good afternoon.
Yeah, please.
In one of the slides, when you showed the results of the Gretl estimation, you compared the two coefficients of capital and labor. I was wondering, because you're measuring employees, number of people as labor, and capital is in terms of US dollars. Can we really compare the coefficients of the
Capital is
two?
measured in terms of number of branches of the banks.
Number of branches. Okay. So if one branch increases, X effect is seen on the Y variable. If one employee increases, Y effect is seen on the dependent variable. Can we really compare the two coefficients?
The very purpose of econometric modeling is to be able to compare the relative effects of variables. Why? I'll tell you 2 reasons for it. First, those numbers that you see on the screen, that Gretl output, 35.2 and then 1519.3, they both are representing or showing the same variable, which is your Y variable output variable. So that's the first cause and area where you establish comparability. And second important thing is, when you take capital, for example, the econometric model, the regression model, estimates the effect of capital on Y while controlling for the effect of labor. And similarly, the variable of labor estimates the effect on Y while controlling for capital. So both are cleanly compartmentalized and differentiated, and both the numbers are then expressed in terms of the same variable, which is Y. And that's the purpose of regression modeling. If you have 5 variables or 10 variables or 15 variables, not all of them will be equally important. So you can't try to change all of them simultaneously or together. You would rather like to spend your time and money only and bet your money on only those variables that have a larger impact, and avoid or keep those variables aside which have a very small impact. Let's say employee satisfaction. If employee satisfaction is the Y variable and the salary is X variable, the number of hours they work is another X variable. Of course, salary is measured in rupees or dollars, and our work is measured in terms of number of hours is measured in terms of hours. You can't compare both of them directly. Here you are comparing their impact on employee satisfaction, not them directly. Very important to know. When you are comparing them here, you are not comparing branches with laborers. You are comparing the impact of branches on output, that is Y, with the impact of laborers on Y. Are you getting it? So the size or measurement unit or the scale difference does not have any implication for the size of the regression coefficient. The size of the regression coefficient, for example, if branches are in very large numbers, you reduce them, say divide them by 1000, your regression coefficient will always remain the same, 1519.3 in this case. That's the beauty of regression. That is why you use regression, to find out or funnel out or filter out those which are critical and have a larger impact on your Y variable, and remove those or keep those aside which don't have that much of impact. So in employee satisfaction example, if salary is having a larger impact on employee satisfaction, its coefficient is larger. You did not worry about hours. You may increase the hours further till you are increasing the salary. People will be happy in your organization. That's the interpretation. I hope you got the idea. You do read Pindick and Rubinfield's book on econometrics. and Damodar Gujarati's book. You will get a much better idea there. Remember, we
Hello.
are comparing the impact, not the variables. Yeah, hello.
Hello, sir. Sir, how can we interpret that coefficient of that interaction term?
Interaction term is what I have included in my PPT. I have not included it in the actual Gretl simulation case study that we saw. But interaction term is complicated. In interaction terms, you need to include the terms whom you are interacting, and then you interpret that interaction term as the combined effect or effect of that X variable, so it's a labor, when even capital is increased along with it. So both together, how do they affect? See, labor may be having a positive impact, but if labor is accompanied, if you are increasing labor along with increasing capital together simultaneously, that together effect, what is that effect on the Y variable is what that interaction term tries to explain. But you need to include the labor and capital variable individually also. Otherwise, that interaction term will become tricky.
Okay, sir.
Yeah, Dr. Shahid has raised his hand. Dr. Shahid Bashir, please ask.
Good afternoon, sir.
Yeah, good afternoon.
Thank you so much for a very wonderful presentation. I had a small doubt in your presentation. Your case study was based on a typical Cobb-Douglas production function.
Yeah, I did not estimate a Cobb-Douglas production function. But yeah, in my actual study, I have used multiple production functions: Cobb-Douglas, translog, stochastic frontier production functions. Yeah.
If we use output as a function of labor and capital, can we say that it's a typical Cobb-Douglas production function?
Not necessarily. For Cobb-Douglas production function, you need to linearize them. So you need to logarithmize them and linearize them, which I've done in my book. So I'll share the book copy also. I specifically
That's why, I mean, in your output, it was in log form.
No, it was not in log form. It was not in no. My output was in level
the
form.
output I could see somewhere in log form.
No, that was for my book in my PPT. That is you're talking about.
Yeah, exactly, in PPT. Yes.
That was in my PPT. Here, I'll share the screen. This is the screen you're talking about here. This is the screen. Here I have estimated multiple production functions, including Cobb-Douglas. Model 3, as I have written here, you can see in my notes, I've written model 3. This third model is a Cobb-Douglas production function. Model 1 is a translog production function. I hope you can see that.
Yes, sir.
Yeah. So model 3 is my typical Cobb-Douglas production function. Everything is logarithmized and linearized. Then you can say you have a Cobb-Douglas production function. But in my Gretl case study, I have not used a Cobb-Douglas production function. It's a simple linear production function.
Okay, sir. Thanks so much.
Yeah, thank you.
Thank you for the clarification.
Yeah.
Sir, shall we continue with few more questions or we can wind up the session?
Up to you. If you have time, go ahead. I am happy to take questions, but the next session should not get delayed.
Yeah, we are, very short of time now. I suggest to participants, if they are having more questions, as they have taken already the details of our resource person, and they can reach him personally on LinkedIn for more interaction. Right now, we are going to, start next session. So I would request our moderator to, give the final remarks, then the rest will start the session. Over to you, Gowhar, please.
At the end, I can say it was a wonderful session. This sir explained econometric modeling, then the theoretical base, how we can put a base for theoretical models, and then how we can test the econometric models, their significance, and a lot of issues were explained. And at the end, a lot of questions was asked by the participants, and sir beautifully answered all the questions. And as sir mentioned, if you have any more questions, you can ask it to sir through Gmail or through LinkedIn, etc. What we can say that it was really a beautiful session, and on behalf of Jammu and Kashmir Economic Association, we are highly grateful to Dr. Bhagirath Baria. And at the end, I would like to thank Dr. Firdaus Ahmad Malik for giving me an opportunity to moderate a session. Thanks a lot, sir. Thank you.
Thank you, everyone. Thank you, Dr. Malik. Thank you, Team JKEA. Take care. Bye-bye.
So before just wait.
Thank you, Dr. Prakash, for the outstanding session. Your expertise and comprehensive insights into the economic metric were truly enlightening. Your ability to convey the complex concepts with clarity and practical relevance has provided us with invaluable knowledge and deeper understanding of Gretl software applications.
Thank you, sir.
We are again also grateful to Dr. Gowhar Wani for exceptional moderation of session. Your dedication and commitment are truly appreciated, sir. We have a high thankful to our participants who are very patient and are showing great enthusiasm to our workshop throughout all sessions till now. So thank you once, sir. Thank you, sir, all. Thank you, sir, all. So we are now moving to the second session for the today's, and it will be moderated by Dr. Manisha Jindal, who are the assistant professor at Lingyas Vidyapeeth, Haryana. Over to you, ma'am.
Thank you so much, sir. A very good afternoon to one and all. I am Manisha Jindal, assistant professor in the School of Commerce and Management at Lingyas Vidyapeeth. And it is my great pleasure to welcome you all to this 10-day faculty development program. Today, we are privileged to have with us Dr. Muhammad Ali. Dr. Muhammad Ali is an associate professor of economics at S3H NUST. Before NUST, he worked for the World Bank on projects related to nutrition and WASH. He is an Alexander von Humboldt Fellow and a member of Global Young Academy. He has published his works on topics related to child health, nutrition, WASH, human capital